Hey there, this is me, Mohammed Vamik. Welcome to the second class for your grade 10 computer sciences. I hope you all are doing well and you are enjoying your new academic year. I wish you all a very best of luck for this year. So, I hope that since the last class, everything is clear to you. Just in case if you have any queries, please feel free to ask me. Don't hesitate at all. You can post a reply either on MS Teams or you can send it to me via email. I'm here to support you, so no need to worry at all. If you have any queries, please feel free to ask me. As far as this class is considered, we are going to take our lecture into the next stage. And in the last class, I discussed with you the PDLC, that is basically the program development life cycle, right? We started with chapter number 7, and we completed the first learning objective. That is that we need to discuss in terms of what is a PDLC, right? That has analysis, design, decomposition, coding, and testing. So I'll be giving you a short review of the things that we have already covered since the last class, and then we will be moving on to the second learning objective that we have right here. So I hope that my screen is visible to you. Okay, so uh, even before starting this, I discussed with all of you that we do have a program development life cycle. The program development life cycle is basically a series of structure, some number of steps that are followed to produce a system, that are followed to produce a software. For example, if you want to create a piece of software, it has to be followed by a number of stages, a number of steps, right? Like if you're creating a piece of software, it is not done overnight. It is not even done single-handedly. It is not even a work of a single person. You need a complete team to develop your software. For example, we do have different softwares that we even use into our daily life. Like we either have MS Word, Microsoft Excel, Zoom, Google Chrome. Just think of these softwares. These softwares are not created a single-handedly overnight. It might have taken years, it might have taken months to complete them, and then their consistent changes into the software has produced this version of that. Even creating a software does not fills or completes the area. You need consistent development. So when you want to create a piece of software, you first need to go forward this stage that as that you need to go along with a program development lifecycle, right? So when a person or organization creates a new program, they will use a structured, organized plan of how you want to create the program. So this is to be known as a program development life cycle, and this contains four stages that we have discussed into the last class. We have discussed that it contains analysis, it contains design, it contains coding, and it contains testing. So if it is analysis basically means that that is the first stage of the program development life cycle that involves that you are investigating the problem. For example, if you are working into an organization and your boss calls you that there is the problem that you need to solve it with the help of a software. So what first you are going to do? The first thing you are going to do is that you are going to investigate it. That what are going to be the requirements? What is the main problem? What I am going to solve? Because just in case if you do not know what the problem is, you never know where you will end. So in the analysis part, what you basically do is that you just look at the problem, you look for against the system, the problem should be explored, the requirements of the program should be identified. And into analysis, I discussed into the last lecture that we use the process of decomposition. What is decomposition? Decomposition is used to split the main area of problem into many smaller areas so that you can reach to a solution. I'm just recalling you all of these stages. Decomposition is basically when you take a system and you split it into smaller and subsystems, which can be converted into even smaller areas so that you completely understand a problem. Sub problems basically allow the developers to identify the requirements for each component. For example, if it is basically a piece of a software, so you would know that a software always contains a number of functions, a number of functionalities. And to completely develop that piece of software, you need to segregate each of the component and you need to work on those components individually. For example, let's take an example of WhatsApp, right? WhatsApp, all of us use of it. So if it's a WhatsApp, we use WhatsApp to send messages, we use WhatsApp to receive messages, we use WhatsApp to make or send, receive or call, we use WhatsApp to send or make images, we use WhatsApp for a daily conversion. And so don't you think that these are lots of features? So what this basically do is that it breaks down your features into every small area, and that is then with the help of that you can work on that individually. So this is basically your analysis part. Then following that, we have after analysis, we had this design area. So design, in the design area, your program designer begin by planning by planning your design, that how it's supposed to be. And into design, we have three areas. We have either a structure chart, we have flowcharts, and we have pseudocodes, right? So design is basically the second stage of your program development lifecycle, which involves decomposition of the problem. So it basically makes sure that if your algorithm is ready so that it can be implemented or not. So let me make it even more clear for you, right? Like for example, if I just flip my screen. So basically, what is a structure diagram? As you can see right here, right in front of me, that a structure diagram is basically developed by composing a problem into sub problems. The diagram has the name of the program, right? For example, if this is an example one, and it is an example of a calculator that you can see right here. So this calculator is basically divided into two of the areas. This is your area A and this is your area B. So if it's a structure chart, this is structure chart basically means that you are splitting your problems into many areas so that you can reach to a solution. For example, if this is an example of a calculator, so what do really happens into a calculator? For example, you are working with 2 plus 2, that's equals to 4. But that's a simple calculation. I want you to focus on the process of that. For example, if you have a software, the first thing that you are going to do is that you are going to input it. Input means you are going to add your calculation. For example, if you want to add 2 plus 2, so first of all, you are going to give that input. So if you are adding the value, that means that you are working with the input. Now, when you press the equals key on the calculator, that means that now it has started to process it. And when the answer generates 4, that means that this is your output. So you can see that I had a simple program. The simple program was basically a calculator, but how I divided this into further three stages. Those three stages are input, output, and process. Similarly, you can see right here as well, all of these are examples of your structure charts. The structure charts basically divide your problem into many smaller areas. You can even name it as a decomposition, because this is what we are doing right here, right? Like there is a lot of ways where you can decompose a problem. So when you split your areas into many smaller tasks, you can see right here that this was your basically main problem. This was your the software that you have to create. And what you have done right here, you have basically splitted them into many areas. You have splitted them into many subtasks so that you can work on individually of that. Right, like for example, here is a chess game. You can see that you have new players, new games, make moves, check one. So these are just some supporting diagrams of your structure chart. Your concept should be clear that a structure chart is when you break down your problems into small areas. Like for example, you are decomposing the problem. So, for example, if you can see right here that this is basically an example two of chess, you can see that this is chess. These are the areas. It can be splitted further. If it's a new player, it means that it has player one, it has player two. If you want to play a new game, it has other more features. I just want to convey you this, that if you have a more number of areas, it makes it easier for you to create that software, because you can eventually segregate that and you can work onto that individually, and then you combine all of them together. For example, if in chess game you want to make a move, so perhaps what you do is that you output the player's turn, you input the pieces, you input the moves, you check if the moves are valid or not, and you move the pieces all together. So that's what makes it this one thing. So that means that one feature basically consists of many areas. So if I discuss regarding in terms of a flowchart, so basically a flowchart is basically a diagrammatic representation of an algorithm, a visual representation of your algorithm. You can say that, sir, our structure chart is also an example of a visual aid, but there is a difference, right? For example, if I'm referring to a structure chart, you can see right here that these are just boxes that is basically segregating your problem into many small areas so that you can basically work out on which solution. But when you work on a flowchart, what is really the difference? The difference is that the flowchart provides you with a diagrammatical representation of an algorithm. Diagrammatical representation basically means that when it comes to a flowchart provides you with distinct distinct objects to work with. For example, if you want to start your algorithm, you use this sign. That means that your algorithm is starting or has either stopped. This is the shape this that is used that if you want to portray a process. This is the shape that you use when you want to work with a decision making. For example, if I want to take computer class, yes. If I do not want to take the computer class, no. If you want to add any input, if you want to add any generate an output. So this is a flowchart. What is the features of a flowchart is that it basically shows you each step in process, right? Like it tells you that how each process is going to work. Is it a decision? Is it a process? Is it an input? Is it an output? That was not something that we were discussing it right here. These were the simple and the plain boxes. So flowcharts basically shows you each step of a process, that in order that each step is performed. So you can see right here, these are some examples of the flowchart. For example, if you want to start a stop a flowchart, you can use this diagram. If you want to add input, you can use this diagram. So you can just go along with these areas. Then again, here is the example of a flowchart. You can check that how it is actually working, how the numbers are added, how they are being calculated. So right now, I'm not focusing on that. I'm just giving you the basic concept regarding the design area that I have right here is of a flowchart and structure chart. Now I'm moving to the third category, that is basically the pseudocode. So pseudocode basically does not refers to any piece of code, right? Like for example, you cannot say that, sir, hey, I want to create a piece of software and I want to create it into a pseudocode. Why you cannot say that? Because basically a pseudocode is not a programming language. It is just a way that how you represent your algorithm, how you represent your thing so that it is quite understandable to you, right? Like for example, if you are basically working into a company named ABC, and this company ABC has a team of many people, and into that team it basically has people's, or it basically has a team of, right, like for example, here you have the team of business graduates, here you have the team of computer science graduates, here you have the team of medical graduates as well. So perhaps what really happens is that if you want to create a piece of software, if you want to create a piece of software, so when you are programming either with a programming language or something, it is quite understandable to the computer science team, right? But it is not going to be understandable with the team of business management. It is not going to be understandable by the team of medical. Why is that? What is the reason? Because they have not understand it. They do not know that how a programming language works. So here comes the way out. What people usually do is that they basically take help of the pseudocode. So perhaps what a pseudocode do? Pseudocode is basically a code like statement that are used to design an algorithm but do not follow any specific language. That means that now if you have created a pseudocode, so just after creating a pseudocode, now it is easily understandable by each and everyone. It is easily understandable by each and everyone. And what is the reason that why it is easily understandable? The point is that it uses simple language. It uses simple keywords. it uses simple English language so that it is quite understandable to each and every one of us. For example, let's take it as an example of this pseudocode. You can see that it is basically inputting a number 1, and then it says that if number 1 is greater than 10, then output too small, else output valid. Now, this is basically an example of a pseudocode, and I believe that I have not written any rocket science right here. You know what? That I'm inputting the number 1, then I'm making a comparison right here. If the comparison is too small, then it is generating this message with the help of an output. Otherwise, it will generate valid. So you see that pseudocode is basically a very simple language. It is basically referring to any code that is not written on a computer to run. So there is no one set pseudocode because it is not a specific language. So we use pseudocode because it has simple keywords, it is easily understandable, and just after this piece of a pseudocode, it can be converted into any programming language. So if I get back to my example, so if I create this software with the help of a pseudocode, so perhaps what happens is that this pseudocode is quite understandable to each and every one of my team because it uses simple keywords, and then it can be converted to any programming language, that is either a Python, it is either a Java. So when you give someone a pseudocode, you basically gives the logic, you basically gives the idea. So it is quite convenient for each and everyone, right? So I hope that these areas are clear to you. Then we move on to the coding part. The coding part is when you decompose the problem into sub problems, right? As we discussed, coding is when now you are carrying out, now you are working on each and every object and you have started the coding part. Now you have selected a programming language and you have started to work on that. So so far, that was basically a recap of what we have already discussed into the PDLC cycle. I just want to get in depth of these concepts so that it's clear to you. Now, as far as this class is concerned, I do have given you a recap of all of the areas, but let's just focus on these areas a little more so that they are easily understandable to you. Okay, so what perhaps we have to discuss is that first of all, we need to understand right here that every computer system is made up of subsystems. When you have a single computer system, it is created up of many subsystems, which are then made up of further subsystems, right? That is basically the concept of decomposition and structure charts. We need to understand that how a problem can be decomposed into its components, right? Like for example, we have input, we have process, we have output, we have storage. Then we can use different methods to design and construct a solution to a problem. And that is either in the design area, the three areas that we have just discussed. So I'm going to take you along with these. So I hope that the concept is clear to you. So first of all, we are going to discuss that understanding that every computer is made up of subsystems, which are made up of further subsystems. So basically, right here, we need to first understand this term, that what do you understand by the term computer system. So computer system is basically a combination of hardware, software, data, communication, people, system, and it is made up of subsystems. So basically, like, if it is a computer system, that means that it should must be having a piece of hardware, it should must be having a piece of software, we should be it should be having data, so that we can communicate with each other and people should be using it. So this is what that basically makes a computer system. So computer system is not something like, for example, if you give it like a computer like a laptop, so it is not that. Every example that contains these areas, for example, if it has hardware, if it has software, if it has data, if it has communication, if people are using that, so this is going to be considered as a computer system. So we have systems that is made up of subsystems. For example, we have smartphones, right? So when it comes to a smartphone, uh, let me give you an example of that. So if you have a smartphone right here, you can see that you have features of that. You have the feature, right, like input, and output. So how you generate that? You whenever you click on the screen, whenever you touch on the screen, it generates an output. So what perhaps really happened, it detects the user input. You also have the option of file storage, where you store all of your important data. You have radio transmissions, where you can manage your incoming and outgoing transmission. So this is basically an example of a computer system, and you can either call it here that I was having the main area as a smartphones, but when I break it down it into subsystems, it is like I have either inputs and output, I have either display and detect user inputs, and I have either the file storage. So this is a decomposition, right? So till here you don't need to get confused into much of that. You don't need to be like, sir, what is going to be asked into exam? You just need to clear your concept that what I am really referring to. As far as your exams are concerned, I'm going to teach you that what is going to come into your exam. So for example, you need to understand that what is a subsystem, what are systems. So whenever we have a system, right, like this was a system, a smartphone, it was divided into these areas. So if I have a system right here, it is basically divided into the subsystems. And for dividing it into subsystems, subsystem basically means that you have a parent and that is being divided into many children. So similarly, you can see that this is going to be considered as a parent. This is going to be considered as a system, and the other areas is going to be considered as a part of subsystem. So for example, all of these are subsystems, and if say subsystem 1, they are being again divided into further areas. So I name this diagram also a name of a structure chart. I also name it as a top down design. Why I consider it as a top down design? Because you can see that it is starting from top and it is going uh, downwards, right? So this is basically a top down design that is starting from top and ending at down. It is also we can see that it is also an example of a decomposition. Decomposition means that you are breaking your problem into many areas. So this is also decomposition and modules. So when I'm referring to modules, that basically means that I'm referring to a single module right here. So this is your module 1, this is your module 2, this is your module 3, 4, right? So all of this can be considered as a decomposition, because a decomposition of a computer system into subsystems, then breaking it into many small areas. So you don't need to get confused into all of these areas. You might be asking, sir, is this a structure chart? Is this is a decomposition? It is a top-down design? Is it a part of subsystem system? The answer is that this is the all of that. There are different processes that aligns together to make this one area. So you can see within this diagram, it is a top-down design, it is decomposition, it is being modules, it is being generating the subsystems of that. So just in case if you have any queries, please feel free to ask. Now, when it comes to a decomposition, decomposition basically means that you are basically dividing your problem into many of the sub areas. So a decomposition always has these stages. We look for input, we look for process, we look for output, and we look for storage. So input is like what you are adding into your system, what you are inputting into your system. The process means is that now the process has initially started. Output means that what it is actually generating. And for the storage part, storage means that how it is actually storing your data. For example, if I am sending a text message, so let's take an example. If I am sending a text message, so perhaps what is really happening is that first of all, I type the message right here, hello. So this is basically your input. Now when I click on send, so sent means that the process has started. Now the message is going to go from my side to the receiver. And if it is going to my side from the receiver, at the same time this message is going to contain some space that is going to be stored either into my hard drive or any memory storage. Now if it is received at the end where I want it to be received, so this means that it has generated an output. So decomposition has four areas. Decomposition has four areas, right? Input, output, process, storage. Moving forward, you can see this area we have already covered. That is a decomposition. You can see that it is being broken down. Uh, Standard methods of solution, structure charts. We have discussed this as well. Structure chart is basically a hierarchical diagram that shows the decomposition of a system. that is developed by decomposition a problem into sub problems. So you can call it decomposition, you can call it a structure chart. Please don't be confused. You don't need to worry at all. If you have any queries, you can ask me. Again, structure chart, decomposition, all same. Flow charts, we have already discussed this. That is basically a way of representing the structure. And flow chart is, yes, standard methods of solution. Pseudocode is just a text-based method of describing an algorithm, right? That is describing your algorithm, that how your program language is supposed to be. So flow chart is done, all of this done. So for all those students who still did not understand the point, I'm repeating it back again. So in case if you do not understand, I'm giving it a review over again. First of all, I have a computer system. What is a computer system? A computer system is every combination of hardware, software, data, communication, and people. If you have these five things, this is going to be considered as a computer system. Now, for example, if it's a smartphone, if you want to create a smartphone of your own, that means that you should be having these five things. But if you're creating a software of that, that means that you need to look forward analysis, design, coding, and testing. So in your design area, what you usually do is that you divide the problem into many smaller areas so that you can work on each and individual of that. So for dividing that, I have three names. I have top down design, I have decomposition, I have module. These are the three names. What is top down design? The name of the diagram, the one right in front of you. You can call it a structure chart as well. What is decomposition? Decomposition is the process of breaking down your problem into smaller problems so that a solution can be reached. And a decomposition has four stages. What are those four stages? Input, process, output, storage. Other than that, what is a module? A module is going to be the single box, the single area of your problem. So this is an example of a decomposition. This is also an example of a structure chart as well. Right here, you can also see this is a structure chart as well. Here it says that it is a hierarchical diagram. So basically, a hierarchical diagram basically refers to that if you have everything just in correct order. For example, first of all, you have an alarm app and so on. You have the other areas right here as well. So I hope that the basic concept is clear to you. This is totally clear to you. Just in case if you have any queries, please don't hesitate to ask. Even if you want, I can record any other lecture of this as well. So please have your queries right in front of me, and don't worry at all. So thank you so much. Thank you so much, everyone. Take care. I will be also be uploading some activities of this, so you can carry on with those and you can submit me your answers. Thank you.